Good morning, everyone. This is the part of preproject. My name is Nisana Tilatinda. Today, I will present you about my topic, the study on the application of genetic algorithm in solving the joint replenishment inventory problem. Let's start with the objective. The objective is applying the genetic algorithm approach to find the optimal solution of the joint replenishment inventory problem. The scope of the project. The first one is study genetic algorithm and applying in joint replenishment problem. The second one is analyze the result from solving joint replenishment problem with genetic algorithm. And before we go to the main of project, I will talk a little bit about relative theory to make sure that you understand joint replenishment inventory, genetic algorithm, and Python language. Let's start with inventory management. How important? The proper management of an inventory system can be provide good and accurate information in order to reduce the inventory cost. An inventory cost consists of the three main costs, which are ordering cost, holding cost, and shortage cost. Look at the graph here. This is the basic concept of economic order quantity, or EOQ. The y-axis represents the inventory level and the x-axis represents time. At time equal to 0, you can see that inventory level equal to Q. And when the time passed by, Q continuously decreases with the demand rate until it meets the point called reorder point. The company will order the product from supplier with Q units and then wait for lead time pass by. The quantity Q will replace at the same time with a zero inventory appear and keep going on this loop. Next is graph of behavior of inventory over time for the joint replenishment inventory. Notice that there are two products on this and it has different inventory level, but both of these two products are out of stock at the same time, and every orders have the same quantity of each product. Why joint replenishment inventory? Because in the real world, you may not find just a simple case like ordering a single item from a supplier, but you will find the case that order many items from one or more suppliers. So that's why joint replenishment problem will appear more often than another case. In this project, we'll focus on joint replenishment inventory. That the objective function is total cost, which consists of three equations. The first one is joint ordering cost per period of time, and holding cost per period of time, and backorder cost per period of time. And these are constraints of the mathematical model. There are 7 constraints. Next is a decision variable, and the most important one is QIJ, that is order quantity of item J from supplier I. The mathematical model that this project being to apply is from the design of joint replenishment inventory model under uncertainty of demands and lead times with backorder policy by Lamida Yusuk, 2002. Associated with heuristic algorithm, it will find solutions among all possible ones, but they do not guarantee that the best will be found. There are many approaches in heuristic algorithm. For example, one is simulate annealing. 2. Taboo search. 3. Neural networks. 4. Evolutionary algorithms. And 5. Swarm intelligence. So, we interested in evolutionary algorithm. The method that exploit ideas of biological evolution such as reproduction, mutation, and recombination for searching the solution of an optimization problem. The genetic algorithm is the most successful among evolutionary algorithms. The basic concept comes from the natural evolution of Charles Darwin, is that the strongest one have the opportunity to survive. And this is the flowchart of general procedure of genetic algorithm. It starts with initial population, selection population, and then genetic algorithm operation, which consists of crossover and mutation, and then go to replacement, and the last procedure is check termination. If it's past the check termination, then it can go out of the loop, the finish. And if it's not past the termination condition, it will go to the selection population again, and then do this loop until it's past the termination condition. Let's go deep into detail of each method of genetic algorithm. The first one is encoding. Encode the initial population. There are many approaches of encoding, such as binary encoding, value encoding, and permutation encoding. And then, before we go to the selection method, we have to calculate the value of fitness function. And then we will consider the value of each chromosome in population that which chromosome can be selected. Selection method can deal with many approaches. For example, in the picture is roulette wheel approach, which the better chromosome will have more chance to be selected. So this approach have a lot of bias. And then crossover. There are two approaches in crossover: 1-point crossover and 2-point crossover. 1-point crossover is this approach will land on one crossover point. You can see in the picture here a pair of parent chromosome and offspring chromosome. Offspring 1 clone the chromosome in front of the crossover point from the father chromosome and then copy the rest from mother chromosome. And offspring 2 clone the chromosome in front of the crossover point from mother chromosome and then copy the rest from father chromosome. Next is 2-point crossover. This will land on 2 crossover points. 2 of offspring chromosome will cross over the chromosome between 2 points from a pair of parent chromosomes such in the picture. Next is mutation method. This method is used to avoid using the same value for more variety of population. By changing some members of population, most of the time, it will land on 4 positions to mutate, with a probability of mutation between range 0 to 0.1. And there are many approaches in this method, such as bit-flipped mutation, inversion mutation, insertion mutation. The next one is replacement method. To replace the previous chromosome with the current chromosome, and then it will get a better generation. There are 2 approaches in this method, which are generational genetic algorithm and partial genetic algorithm. And the last method is termination condition. Condition for stopping operating when it has already found the optimal solution. Python. Python language is one of the easy language to understand and full of convenience tools. For example, a lot of free packages library, if, while, and for loop statement. And the next one is example of joint replenishment problem. This is a table of summary of cost, demand, and holding cost of product per day. T equal to 14 days, and decision variable is order quantity of item 1, item 2, item 3, and 4. And constraint is order quantity must have more than demand per day of item multiplied by T. That is time. And this is the objective function, minimize the total cost. And given mi is a number of items I that left each day. This information are from the research of Pim Sili Sangchan. The topic is Inventory System by the Inventory Theory. Case study by Nong Kha Cooperative from the Faculty of Science, Khon University. And this is the flowchart of the solution by applying the example with the genetic algorithm. Let's start with initial population. We use the Gaussian elimination to encode the initial population, and then enter the constraint, and then go to the fitness function. Basically, fitness evaluation composed of calculation of the objective function. Here, the fitness function is total cost, and then go to selection. But we use the ranking selection for avoid the bias and consider each condition, and then go to the crossover. This study will use 1 point crossover, which is having a random position with crossover rate of 0.8, and then mutation. We'll random the chromosome which has already passed crossover method, and then random a position that want to be mutated with probability of mutation 0.02. And this study, which want to minimize total cost, will define the condition as if population run to 100 iterations, and if it doesn't find the total cost which is smaller, or it finds that the results are constant for the entire 100 iterations, then the operating of genetic algorithm will stop immediately. This is the result that get from Python, but it's quite not make sense because I'm not good at Python and I cannot add some constraint in it, and I will do it better for next time. My progress. In preproject, I start with understanding the math model. That is a joint replenishment problem. Then choose the algorithm to solve the problem. That is genetic algorithm. Then choose program as a tool. So I choose Python. Then study how to apply joint replenishment problem with genetic algorithm by using Python. And then I present my preproject concept today. And in the future of my project, I will study more about Python. Then make sure that I really understand the model, and then do the programming model. Then analyze the result and conclusion. Finish. Thank you for your attention.